grouper in the Gulf of Mexico over the last 20 years. And as a result of these latest stock assessments and interim assessment updates, let me see if I can get this to run. There we go. FWC, in concert with the Gulf of Mexico Marine Fisheries Council, enacted a series of emergency pieces of legislation in 2022, which began to take effect in 2023 and 2024. Essentially, they reduced the recreational gag quota by around 80%, and they shifted the fishing season from an onset of June down to an onset beginning in early fall, so September 1st start date. And so to get an idea of what this looks like, the recreational season in 2022 was essentially this. And after the emergency action, the 2023 season looked initially something like this, a 2-month season beginning in September, and was actually whittled down even further because we initially exceeded the quota, and so they had to do an emergency stop. So that's quite a drastic drop in the recreational fishing season. And so, personally, I think that this was this was probably the right call. When you're faced with a population decline, you want to take decisive action. However, as the initial emergency has receded a little bit, it would pay to take a look at whether these different fishing regulations are actually achieving the goals that they were intended to have. And that's because there are several assumptions that these managers make. And I agree. I think that this was absolutely the right call. But these assumptions that managers make when they enact these different fishing regulations, it would pay to evaluate them really carefully to make sure that they're achieving their intended goal as we move from the initial sort of emergency action phase into a stock rebuilding plan. And what I mean by this is that there are a couple of different assumptions here. And the major one is that reducing fishing seasons reduces the number of fish we kill or otherwise remove from the population. And one of the first potential problems, because these might not actually be happening, but this is, again, potential problem we need to investigate, is that fishing effort may not be proportional to season length. What do I mean here? Well, again, we have our 2022 season, and just imagine that fishing effort in terms of angler trips, that's going to be the unit for the rest of this talk, is evenly distributed throughout the season. Well, the assumption here is that when you reduce the season, all of this extra fishing effort goes away. It either gets reallocated into maybe a different fishery, or it just kind of disappears into the ether, right? However, what we know from a lot of very popular recreational species is that occasionally you see something like this, where anglers have a reduced opportunity to actually embark on fishing trips, and so they just cram all of that extra effort into that tiny window that remains. This is known as effort compression or effort concentration, and you can see it here in a 2020 paper by Nick Farmer, John Fresky, and Dave Records going over the recreational red snapper fishery. Whereas you can see as the number of days in the red snapper season goes down, you see higher and higher numbers of catch per day, or higher units of catch per day. And so what's happening here is that these anglers are cramming in as much fishing time as they can in the smaller time window that remains. So that's potential problem number one. Potential problem number two is that people don't stop fishing on reefs just because one reef fish species isn't open for harvest, right? What I mean here is that gag are one of the, I believe, 32 different reef species in the Gulf of Mexico multi-species reef fish complex. And they like to hang out on these structurally complex reefs all along the western Florida shelf. However, they aren't the only popular reef fish species that occur there. You have other popular species such as mangrove snapper, red grouper, and again, like 28 other ones. And so what happens here is that if you're Bob, and I don't mean to pick on anyone whose actual name is Bob, I just picked one out of a hat. Bob is going out fishing for, say, mango snapper, right? These guys don't actually have a season, they're open year round. He knows that gag grouper are closed, and so he's going to be actually targeting, maybe it's a weekend in fall, he's also going for red snapper as well. So he goes out and fishes, and maybe he's not the most experienced angler in the world. You know, usually snapper species sit a bit higher in the water column than grouper. They tend to hang out a little bit closer to the bottom, but Bob doesn't know that. And so even though he's targeting red snapper, what's going to happen is he might catch a few gag as bycatch. And if these guys have high discard mortality, right, and you're closing the season, particularly at a time of year when there's high discard mortality, well, that's not actually lowering your fishing pressure. That's just lowering the number of fish you're allowed to keep and bring back to the dock, right? So that's something that we need to consider. And that brings me back to problem number three, which potential problem number three. I want to really underscore potential here. And that's related in that closed seasons when discard mortality is high may not actually decrease fishing pressure the way that these regulations are intended, right? So again, I'm going to get a lot of mileage out of this little calendar animation I made. Initially, you have this 2022 season, and we expect that discard mortality might vary throughout the year. It might be a little bit higher when the water is warmer in summer months and a little bit colder in fall and winter months. Why might that be? Well, there's a bit of evidence that these animals, or at least anecdotal evidence, that these animals tend to move a little bit deeper when the water gets warmer. And that means that essentially what they're trying to do is escape those warmer surface temperatures to hang out a little bit closer to the bottom when the water is cooler. When you pull up a gag that's from 100 feet, that's going to experience more barotrauma than a gag that you pull up from 40 feet. And as a result, there's going to be potentially higher discard mortality that occurs to those gags that are a little bit deeper. So if you have assume that you have discard rates that are homogeneous throughout the fishing year, not a great assumption, this is just a heuristic. Essentially what you're going to want to do is really, you may want to put your season where discard mortality is highest. And the thinking there is that the fish that you're otherwise going to catch and discard that are probably going to die, you actually get to keep. If you have a fixed amount of quota, meaning that there's a fixed harvest that we want anglers to take out, you might as well be pulling from this bucket, because this way you're not actually wasting any fish. The fish that die end up on your dinner plate, not back in the ocean and being munched on by a shark or something else, or maybe a seagull. However, if you move the season, let's see if this works. If you move the season to a place later in fall when there's lower discard mortality, well, these guys are still going to be harvesting the same amount. There's still a catch quota, right? But they're going to be discarding all of those fish earlier in the year when discard mortality is higher, right? So actually, you're going to be potentially not reducing your fishing pressure that much at all. Because again, you're going to have fish that you're going to be discarding that are just going to die or have a higher likelihood of dying. Again, all hypotheticals, may not actually be what's going on here, but these are all things that we need to evaluate. And so when we're considering or evaluating the most probable outcomes of these different fishing regulations, we need to consider things like recreational effort and angler behavior, harvest and discard rates, as well as seasonal discard mortality, right? And all of these things together will help us, it will inform us in terms of how these regulations are going to play out in reality and whether they achieve the goals that are intended. So that's what I come in. So my research is essentially over the last year has been to evaluate the efficacy of gag fishing regulations between 2022 and 2023, and really focusing on that shifting temporal window for when we actually started the season. Here, I essentially developed a multi-model framework to predict things like recreational effort, gag harvest, and gag discards. And once I had this framework, I then used it to simulate multiple season start dates and season durations. And specifically, I focused on June, which was the initial start date from, I believe, 2015, at least 2015, all the way to 2022. I'm blanking. It might have been the start date for a few years prior to that. A September start date, which was the what they changed it to from 2022 to 2023 and even 2024, and then potentially a November start date, just to see what would happen if we moved the season to begin later in fall. And so once I had that. Once we had accomplished those simulations, we then examined the corresponding dead discard projections. Here, I want to focus on the fact that I used NOAA's Marine Recreational Information Program, which is basically tabulates recreational statistics on things like gag harvest, gag discards, and recreational effort in most places throughout the United States, but specifically I focused on the west coast of Florida, and that's because this is where like 98% of gag have been landed recreationally since about 2004. Here I focused on two different sub-state MRIP regions. These are going to be the Panhandle in purple and the peninsula over here in green. And I think I've gotten ahead of a few of my my bullets. So yeah, these are going to be referred to as the Panhandle and Peninsula throughout the rest of this talk. I'm going to get a lot of mileage out of these animations. So let's go on ahead and look at what each of these different models are going to entail. So I'm a Bayesian statistician, and so all of these models are going to be Bayesian generalized linear models. For recreational effort, I used the gamma model because this response variable is continuous and bounded by 0. So gamma distribution seems like the right choice. For harvest and discards, I used a hurdle gamma distribution. Here, there's going to be zeros, particularly when gag is out of season. There's not going to be a whole lot of gag harvested, usually. hopefully, if the season is closed. And so we accounted for that by including a hurdle model in each of these other two components. For what goes into these models, we included things like different fishing regulations, both for gag grouper and for red snapper, because red snapper is by far and away the most popular recreational species in the Gulf. So anglers might be motivated to change their behavior based on both of these two species, not just necessarily gag. In addition, we had season length to account for those different concentration effects that I had mentioned earlier. Seasonal terms, a couple of different sine and cosine waves that we included just to account for seasonality, but we also included different environmental variables such as wind speed and water temperature that I pulled from different NOAA stations along the coast. And then we had economic terms for modeling recreational effort, things like inflation-adjusted fuel prices and median household income. And then finally, we had fish abundance, because CPUE from previous years are going to definitely impact how many gag you catch in the next year, right? How many gag you harvest is typically going to be related to how many you can harvest. But in addition, it will also probably motivate recreational anglers. People like fishing for their favorite fish, and if they aren't able to catch their favorite fish with some regularity, they might be less motivated to go out the next year. So that was the thinking for all of these terms. However, we also had recreational effort actually inform our gag harvest and our gag discard models. The thinking being that if no one's out fishing, there's not going to be any gag to be caught. And so you need this as a predictor for these other two models as well. So when we're actually running our simulations, I want you to keep this in mind, because for all of my simulation frameworks, recreational effort is going to be estimated first, and it's going to inform the projections for gag harvest and gag discards moving forward. Moving to recreational effort specifically, what I'm going to show you here are going to be the observed angler trips. Again, that's going to be my unit for angler effort, and that's going to be these black dots. In hindsight, I wish this had been a little bit bigger. And this is going to be in the panhandle up top and the peninsula down at the bottom. What you have here is going to be basically the model's median fit. That's going to be that solid blue line. And then these bands, are these light blue bands, are going to be 80% Bayesian confidence intervals, right? So it's going to be a probabilistic estimate with some uncertainty. And for the panhandle especially, the fit was pretty darn good. It really nailed that, that really strong seasonal effect that you see primarily due to the red snapper fishery being open and very popular in the panhandle. For the peninsula, it was a bit noisier. It generally tracked to the mean value. However, it did miss some of the peaks, the erratic peaks, either at the high end of the time series, or it missed some at the bottom as well. So a little bit squirrelier, a little more uncertainty, but generally I would judge this as fairly good fits. And it also predicted out of sample pretty well, which I won't be able to get to for the remainder for this talk, but I can answer questions on that. In terms of predictors that we found were important, the amount of time open in a given month that was open for red snapper or gag grouper harvest both increased the expected number of angler trips that we would observe in a given month in a given region. No surprise, if your favorite fish is available to be harvested, you're going to want to go out. Moreover, the length of the red snapper season decreased the expected number of angler trips. And again, that's consistent with what we already know, right? The shorter that red snapper season is going to be, the more effort anglers are going to cram into the harvest season that's going to remain to be open, or that's going to still be open. That's that concentration effect that I'd referred to earlier. However, if you notice, gag grouper did not, the season length for gag grouper did not impact angler trips in either region, something that I thought was rather interesting. But in addition, the indices of abundance, basically recreational CPUE for gag, red snapper, and red grouper, which is the third most popular species recreationally in the Gulf Coast, the Florida Gulf Coast. These all increased the expected number of angler trips, particularly in the peninsula, but also to some extent in the panhandle as well, at least for gag and red snapper. Red grouper isn't really caught up here, so that didn't really motivate angler trips in that region. But anyway, moving forward to, oh, I'm sorry, my upshot, of course. Because we didn't necessarily see any effect of the season length for gag grouper in this, or how that, or we didn't necessarily see an effect of the season length for gag grouper on angler trips. And so one of our main conclusions for this paper that we got out was essentially that angler concentration, or the effort concentration, is not yet taking place for gag. At least we couldn't see it with the available evidence that we had. That doesn't mean that if as seasons become shorter and shorter and shorter, that it might manifest later on. But at least with the data that we had from 2004 all the way to 2023, we did not necessarily have evidence to see it take place so far. Now, moving to gag harvest, excuse me. This is again going to be a hurdle gamma model, and I'm going to be presenting results again on the from the Florida Panhandle and the peninsula. And again, this is just the harvest in numbers of gag in either region for any given month from 2004 to 2023. What you can see here is that the models was able to track the peninsula a heck of a lot better. It's a really tight confidence interval, and it tends to map to the estimates quite well. For the latter half of the Panhandle, particularly after 2008, the model generally tracked pretty well to the observed estimates, but things were a little bit erratic and a little bit squirrelier from 2005 to around 2008. I'm not 100% sure why that is. It seemed like CPUE didn't quite map onto harvest the way it had in later years. But generally speaking, at least for the later half of the time series, which is what I was most concerned about for simulations, this seemed to map on quite well. In terms of effort that, or in terms of predictors that we found important in the gag harvest model, the amount of time open to harvest gag grouper in a given month positively increased harvest, or positively was associated with harvest, which was unsurprising. The amount of time open to harvest red snapper decreased the expected abundance or the expected harvest, all else equal, in a given month. And essentially here, what I'm assuming is going on is essentially effort switching. If you have two of your favorite fish that are open for harvest, it seemed like from the evidence seemed to indicate that folks were switching to red snapper, which was a preferred species, if the both species were available to be harvested. That's my best guess as to what was going on here. In terms of recreational indices of abundance, this, surprise, surprise, had a positive effect on the amount of gag harvested in the following year. Again, gag harvest is going to be positively correlated to the abundances that we estimate to be occurring out in the Gulf. And then lastly, again, unsurprisingly, angler trips positively were associated with positive numbers of gag harvested in either region. And then in terms of environmental variables, temperature actually had a negative effect on the number of gag harvested. What I can basically, what I've been able to glean here from literature is that a number of reef species catchability scales with water temperature. In certain warm water reef species, warm and cold kind of with an asterisk next to it because these are all tropical species. Warm water loving species catchability tends to increase with water temperature, and more cold water species catchability tends to decrease as the waters begin to warm. And what we found here pretty clearly was as the water began to exceed around 28 degrees Celsius, gag tend to bite less frequently, and so catch rates tended to decline. You'll see this with both gag harvest and the model for gag discards. In terms of gag discards, again, we kind of had the same effect with a little bit of squirreliness in the earlier part of the time series for the Panhandle. So essentially here, the projected discards that the model expected versus the observed values in the peninsula seemed to track extremely well. The model was able to predict with a pretty high degree of confidence what the monthly discard rate was going to be in the peninsula. In the Panhandle, again, after around 2010, 2008, the model tended to fit relatively well to the observed data, although there is still a little bit of squirreliness and a little bit of extra model uncertainty from 2005 to 2008. And again, my best guess for what's going on here is that for some reason, the indices of abundance didn't quite map as well onto observed estimates the next year in the Panhandle in that time span. In terms of important predictors, the fraction of the month open to harvest both gag and red snapper both increased the number of expected discards. Abundance also expect to increase the number of expected discards. And here, again, it's not surprising. If there are more fish available to be caught, that's going to tend to correlate to a higher number of fish that you do catch. And so that will also tend to increase your discard rate, specifically if you have a finite bag limit. So if you only have a bag limit of 2, you catch your 2 gag, and then you discard the rest. So all else equal, a higher index of abundance should correlate with higher discards, and that's what we saw here. In terms of angler effort, again, if there are more people out fishing, more fish are going to be caught and more fish are going to be discarded. So that was pretty much unsurprising. And again, you saw this temperature effect where as the water got warmer, then you would go ahead and see a lower catch rate, which corresponded with lower discards. In terms of the fraction of the month open to red snapper, increasing discards, what's happening here, if you remember my little animation, Bob apparently is not as discerning as we would hope. Again, more experienced anglers are generally able to target different areas in the water column and target these different species with a little more accuracy and a little less bycatch. But the average angler, even if they're targeting red snapper, might still catch a few gag as bycatch and discard them. And so if they're, because red snapper is such a popular species, typically what we ended up seeing was that the fraction of the month open to harvesting red snapper increased, we also saw some gag discards. However, if you remember some of my hypotheses, I was actually expecting that the gag discards would either stay flat or actually decrease as the fraction of the month open to gag increased. And this was what I was thinking was all of those gag that you were catching and discarding would kind of go into your harvest bucket. I was flat wrong. What's happening here is that as anglers are targeting gag grouper when the season is open, that's both going to increase your total number of gag harvested, and it's going to also increase your total number of gag discarded. So again, this might be my naivety. I was, before I got here, I was looking at a commercial blue crab fishery, the commercial blue crab fishery, which is a little bit different from here, from a recreational reef fishery. And so this was somewhat surprising to me. My hypothesis again had been that, you know, what if you had a if you're catching these animals throughout the year and the season is open, you're just going to keep more of them. But this seems to be indicating that anglers are actually going to be targeting gag with more specificity, and it's going to increase both their harvest and their discards. Moving towards the simulation framework, once we had our models tested and well validated, this was essentially what we did for each individual month to get an idea of how these different season simulations would affect total harvest, total discards, and dead discards. Where here we started with a counterfactual data set, where initially we had a given season start date, whether it was June, September, or November, different economic variables that we held fixed and constant at every individual month, different weather patterns such as average wind speed and water temperature, again, which were held at fixed monthly values, and then the length of the fishing season. Once we had the simulated data set, we then plugged that into our effort model to generate consolidated effort estimates for both the Panhandle and the Peninsula. And then we used, remember, because effort estimates would inform our harvest and our discard models, we used our counterfactual data set as well as our effort estimates, and we plugged that, we used that as predictors in our harvest and our discard model. That gave us our estimates of harvest and discards for each individual month. For converting harvest in numbers of gag to pounds, we simply multiplied that by the average weight of gag harvested each month from 2021 to 2023, so the last 3 years. Seemed relatively reasonable. And that got us harvest estimates in pounds, which I'm just going to refer to as landings to kind of distinguish between the two. And then to get dead discards, we essentially took a monthly discard mortality rate from Sauls et al. 2014, and this essentially, we multiplied these monthly discard mortality rates by our discard estimates to get our dead discard estimates here. But there's a little bit of a problem that I found out later on, which was that essentially the calendar year is going to be informing our angler behavior, and our the season in the calendar year is going to be informing our angler behavior, right? When the season is open is going to effectively affect when these anglers are going to go out and embark on fishing trips. It's going to affect how many fish they catch and how many they bring back, and it's also going to affect their discards. But the problem here is that the length of the season is set based on a fixed recreational quota. There's a certain number of pounds that we're able to remove from the Gulf every single year. And once we hit that quota, or we're projected to hit that quota, then the season shuts down, it stops. So we needed to figure out what the length of the fishing season was going to be for each season start date, because they're going to be different. The catch rates are, so if you imagine that this line is our recreational fishing quota, if the catch rates are a little bit different from month to month, that means they might hit their quota a little bit sooner in June than in August, which it might take a little bit longer. So because we wanted this to be a realistic simulation, we wanted to make sure that our seasons were set to a fixed length to where the harvest always eventually totaled the actual annual catch limit, or that recreational quota. And so we needed to do a little bit of simulating to figure out what that would be. So what we did was we took this simulation framework and we plugged it into this iterative procedure, where essentially we started with our counterfactual data set, a one-day gag season, and a fixed start rate, either starting June 1st, September 1st, or November 1st. We then ran our little simulation, and we determined if the landing, so that the total number of gag harvested in pounds, exceeded our recreational fishing quota. One day, usually that's, unless everyone is out fishing, that's probably not going to happen. So if the landings did not exceed the quota, we update the conditions to increase the season by 1 day, and then we kind of rinse and repeat. Once we finally have a season length where the total landings exceeded the quota, we stopped our simulation, and that was the season length. We then ran our simulation and ran our projections and evaluated the corresponding change in dead discards for each of those season start dates and that season length. To give you an idea of what this looked like, these are going to be our simulated cumulative gag landings in pounds from both regions combined, using the June start date, the September start date, and the November start date. And you can see the length of the season in days based on when the median cumulative gag harvest in pounds exceeded or met that recreational fishing quota. And then these bands are always going to be an 80% Bayesian credible interval. And so what you can see here is that, yeah, based on changes in the catch rate, what you can see is that the June season and the November season, on average, typically had around were typically projected to be a season length around half of what was in September. So that was important consideration. But another useful advantage of this strategy is that because harvest was basically held constant for each of these fishing seasons, then we could essentially compare the total number of dead discards directly, or the estimated total number of dead discards directly, in order to compare how fishing pressure changed as you looked at different season start dates throughout the year. So to get an idea of what we did here, essentially, we initially compared all of our simulations relative to a baseline. So we wanted to know what would dead discards be for each individual month if there was no gag season at all. Gag was closed for the entire year. And because people are still going to be out fishing, they're still going to be out fishing on these different reefs and catching and discarding gag, right? Maybe you have a peak in June and July when people are out focusing or fishing for red snapper. And maybe otherwise there's not quite as many gag being caught or discarded throughout the year. Then we imposed, let me see if I can get this to work. We imposed our fishing season, say that it was from September to November. And we then looked at what the corresponding projection was going to be for total dead discards for that June season scenario, right? And because the only thing we changed in these different models was the length of the gag fishing season and when it occurred, remember that all of our economic variables, all of our weather variables, all of our abundance variables, those are going to be fixed at monthly values, and the only thing we're changing is going to be for those months when the season is open. So what happens is that we can actually just directly compare what the expected change in total discards are going, or dead discards are going to be, by simply subtracting the projected estimates in our season scenario from our baseline. And that gives us essentially what the change in dead discards are going to be as we move from a no season scenario to a season scenario starting in June, September, or November. So I want you to keep this in mind. Whoop, and I missed an animation. So yeah, we're going to be focusing particularly on when the season is open for these different scenarios, and we're going to be comparing that to our baseline value. So I want to, whoop, and I missed my bullets, shoot. Anyway, so I want you to focus on this window right here, because this is what's going to be informative when we're looking at the change in dead discards from each of our scenarios in both the panhandle up in the top and the peninsula in the bottom. And if you notice, there's not really much of a difference between the baseline and when the season is turned on in the panhandle. Basically, these guys are not really focused or motivated for fishing for gag in the panhandle. They don't catch a ton anymore up there anyway. And so generally speaking, because they're motivated for targeting a different fishery, we didn't see much of a change in dead discards in that region. However, what we did see was quite a big change in the expected number of dead discards as we looked at a June season, a September season, and a November season in the peninsula. And that's because gag are primarily caught and landed along the western peninsula of Florida. And something that I thought was quite interesting was that, in contrast to my expectations, because again, I thought that essentially June would be the season that would have experienced the lowest number of dead discards for gag, I was flat wrong. In fact, what the model was indicating was a November season or a September season, so those early and late fall months, actually corresponded to the lowest number of, the lowest change in gag discards, dead discards, from our baseline value. What you see here, these dots are going to be the median expected change from that no season baseline, and these bands are going to be, again, 80% credible intervals, or confidence intervals, excuse me. So what's happening here? Well, essentially, what was going on is that when the gag grouper season was open, again, these guys are now going to be motivated and targeting gag in these different regions, particularly in the peninsula, which is what this graph is showing you. And again, this is just going to be the number of discards, so not dead discards, but discards, when the season is turned on in June, in September, and November, relative to a baseline value in red. And so what we're seeing here is that when the season is open, these guys are actually going to be discarding quite a bit of gag. And when the season is closed, that value is actually pretty small. And so what becomes important here is when we superimpose our seasonal discard mortality rates. So this is going to be the expected discard mortality rate for every month in the peninsula. And this is based on research from Bev Sauls over at FWC and our 2014 paper. And what you can see here is that the overlap becomes really important. Even though these three different regions have comparable numbers of total number of fish discarded, because this area overlaps considerably with a time of year when there's high discard mortality, that's going to matter a heck of a lot more. Even though these two seasons actually corresponded with a slightly higher number of gag discards relative to that June season, it mattered a heck of a lot less because it was occurring at a time when season mortality was quite low, leading to a reduced number of dead discards in aggregate relative to the baseline value. So in conclusion, the recent change from season start dates from summer to fall ended up increasing season length, which is always good. Anglers like to fish, or like more time to fish, generally speaking. And it also seems to have decreased the expected number of dead discards for this fishery. And because harvest is held constant at some quota, essentially what happened here was that this suggests that this shift in season start date is going to lower our fishing pressure overall. So this was a good thing, right? These guys acted on their, I won't say gut instincts, I don't think that's correct. They had a limited amount of knowledge as to what the angler dynamics were going to be as a response to these different fishing regulations. And they absolutely had the right idea for how these dynamics were going to play out. And so this was sort of the best case scenario. Even though a November season would have resulted in slightly lower dead discards, if you're kind of balancing different priorities and you're going to prioritize season length with a roughly comparable change in fishing pressure, then the September season seems like it was going to be the way to go. And the reasons for why are going to be, first, that effort concentration isn't yet occurring for gag, so that's really going to help in terms of meeting that assumption that lowering the season or shrinking the season is going to see a corresponding reduction in fishing pressure, excuse me. And the other big reason is that gag discards actually increase when the season is open, and they typically go down quite a bit when the season is closed. So that means that targeting these animals are going to be what drives discards in this fishery, and that was something that I certainly wasn't initially expecting going into this. And then finally, the much lower discard mortality in fall is essentially what's really driving this. Even though the total number of discards aren't really going to change from one season to another, depending on when it's open, because you have a finite window and there's differences in the catch rate, we actually saw very similar numbers of expected total dead discards. Because of that lower discard mortality in fall, that wound up with us observing, or at least anticipating, a lower number of dead discards in the September and the November seasons. So again, kind of to graphically build upon this or reiterate this, again, we have our seasonal mortality curve, and we have our expected number of dead discards, or expected number of fish discarded. And what happens in reality, or at least what the model expects, is that if the number of gag discarded is going to be proportional to when the season is open and available for fishing gag, then you actually do want to have your gag season when discard mortality is low. Because if gag discards are only going to increase when the season is open, you might as well put it in a place where those fish are going to be more likely to survive. With that, I'll say thank you for listening to all of my bad jokes, including, I believe, 2 Katy Perry jokes. I'm really sorry about that. If anyone's interested in the first paper, Modeling Recreational Effort, that was out in Fisheries Research. The other paper is or draft MS is being prepared for publication now. I just want to thank a few folks. Mike Drexler, who is a USF alum, was a co-author on the effort manuscript and was informative in this, the rest of the modeling research. And then I wanted to thank John Fresky, Bev Sauls, Chloe Ramsey, and Tiffany Cross, both at the Gulf of Mexico Fisheries Management Council and at the Fish and Wildlife Conservation Commission, just for helping me wrap my head around the dynamics of the system. Because again, I was a blue crab guy before I got here. And so moving to a recreational fishery has been a challenge, but a fun one. And so with that, I'm going to turn it over to Gertrude over here. And if anyone has questions, just let me know.